Now we turn to what a hash table actually is. Let's build it from an array and a hash function. A hash table is an array of m buckets plus a hash function. The hash function turns any key into a bucket index from 0 to m-1. Follow this pipeline from left to right. The key cherry goes into the hash function. Out comes a big number called the hash code. We reduce that number mod m with m equal to 8. That lands on a small bucket index too. The hash function computes where a key starts looking. We call that its home bucket. When two keys collide, the final slot can differ from that home bucket. The same key and the same table size always give the same index, but two different keys may still land on the same index. That is a collision. Right after you create a hash table, every bucket is empty. In a chaining table, the array does not store keys directly. It stores where each key's chain begins. This table has 8 buckets, indexed 0 through 7. All 8 are empty right now. So m equals 8 buckets, all empty. This is the same cell array from chapter 2. We just read it differently now. Let's fix the vocabulary. A bucket is one slot of the array. A collision is two keys hashing to the same bucket. The load factor alpha equals n over m, stored keys over bucket count. It measures how full the table is. Every hash function must have two properties. The first is deterministic. The same key always yields the same index. Otherwise, a stored key could never be found again. The second is uniform. Keys spread evenly across all buckets. A clumped hash gives long chains and long probes. You may think any hash works as long as it is consistent, but a hash that sends every key to bucket 0 is perfectly deterministic and useless. The table becomes one big O of n chain. Uniformity is what matters most, not just determinism. Let us try a learning check. The table size m is 8 and the hash function is hash of key equals key mod 8 for integer keys. Part A, which bucket does key 19 go into? Part B, does key 11 collide with it? Pause and work it out. Here is the answer. 19 mod 8 is 3, and 11 mod 8 is 3 as well. So yes, they collide, both landing in bucket 3. Before we name any fix, let's make a collision happen by hand. Your turn. The table size m is 7. The hash is h of k equals k mod 7. Insert keys 10, 17, and 3 in that order. Which bucket does each go into? Is there a collision? Pause and predict. Here is the answer. 10 mod 7 is 3. 17 mod 7 is 3. And 3 mod 7 is 3. All 3 keys go into bucket 3. That is a three-way collision on the very first few keys you insert. Now the point that follows from it. You may think a good hash function avoids collisions. It cannot. With more keys than buckets, two keys must share a slot. That is the pigeonhole rule, and no hash function escapes it. So a hash table's job is not to avoid collisions. Its job is to handle them. The next two sections show the two ways to do that: chaining and open addressing.